So I'll now discuss about different forces which we come across. The first which we are going to discuss is about weight. The basic force. Weight is all about the amount of gravitational force, the amount of gravitational force acting on the body, is called weight. Right. It will always act on the body in downward direction because we assume that Earth is in downward direction. It is only directed towards center of the Earth. So we in problems will be assuming that Earth lies in downward direction. So it will be mg. So that's weight. I'll discuss in great detail about gravitational force in the chapter of central forces. That's all about weight. Wherever you find the block or any body, just apply mg in downward direction, because we assume in every problem that we are doing the problem under gravity and Earth lies downward. We are above the Earth and Earth is downward. So that's the force. That's the basic force which you will find in all kind of problems. So that's about weight, right? That's about weight. And I'll move to the next force. That's called you may think is so small, but then we will discuss in great detail about gravitational force in the chapter of central forces. For the right now, you just have an idea that weight is mg, mass of the body, and g is acceleration due to gravity. I write it here. Weight is mass into mg. So m equals to mass of the body, right? And g is acceleration due to gravity, and this g is 9 meter per second square on Earth, or approximately 10 meter per second square, right? So that's weight. If it is 10 kg, 10 into 9.8, 98 Newton. That's weight. The next important force, which is really very important, that is normal reaction. Normal reaction, right? What is normal reaction? When does it act? It acts when the motion of body is constrained, and the motion of the body is constrained in certain direction, and then it acts in direction opposite to I should write it opposite to the direction in which motion of the body is constrained. It acts in direction opposite to the direction in which motion of the body is constrained. Clear point? And third, its magnitude depends on degree to which the motion of body is constrained. So it acts when motion of the body is constrained in certain direction. It acts in direction opposite to the direction in which motion of the body is constrained. Its magnitude depends on the degree to which motion of the body is constrained. To explain this, I'll take an example, right? Let me take an example. Only by example I can explain this. Suppose we have a body of mass, say not m, say 10 kg. We have a body of mass 10 kg is falling freely under gravity. Now I have a body of same mass 10 kg kept at rest on the surface. I have the same body of mass 10 kg moving in downward direction along with the surface by, say, an acceleration of 2 meters per second square. Now I have the body of 10 kg mass along with this floor is moving upward with 2 meters per second square, right? I have these 4 cases. Right? This is a freely falling body. This is a body kept on a static surface. Say I can call this a body in a lift which is at rest. So this is a body in a lift which is at rest. This is a body in a lift which is going down with 2 meters per second square. And this is a body in a lift which is going up with an acceleration of 2 meters per second square. The other 4 situations, the other 4 cases, right? The other 4 cases which you have. In all the cases, you have the weight acting on it. 10g. This is 10g. This is 10g. Now, in this case, in the first case, this body, the motion of this body is not at all constrained. The force acting is 10g and it will go down with 9.8 meters per second square. Under the effect of this force, it will go down with 9.8 meters per second square. Right? So this is unconstrained. I'll call it. The motion is unconstrained. You leave the body, right? You just drop the body. Body is under gravity. It's free fall. It's unconstrained. There is no question of normal reactions since the motion of body is not constrained. Look into this case. The force acting on the body is 10 kg, 10g. Under the action of this force, this body would have moved with an acceleration of 9.8 meters per second square. Under the action of this 10g force, that is 100 Newton force, that is 98 Newton force. This body would have moved with an acceleration of 9.8 meters per second square. But we are finding that this body is at rest. It means what? The surface is constraining the motion of this 10 kg block. So the motion of this body is constrained in downward direction. Motion of this body is constrained in downward direction. Right? It means there must be a normal reaction acting on this body in direction opposite to the direction which motion is constrained. Who constrains the motion? Surface is constraining the motion. So surface must have been exerting a force N in upward direction. Surface exerting a force N in upward direction, and by applying this N, it is constraining the motion of 10 kg mass. When I am standing on a floor, when I am standing on, say, first floor, second floor, or ground floor, then on me a force equal to my weight is acting on me. Weight is acting on me. But I am not going into the floor. Why? Because the floor is exerting a normal reaction on me, which is balancing my weight, and I am at rest. So my motion is constrained. The surface is constraining my motion. The surface constrain my motion by applying a normal reaction N. And as a reaction, this block will also apply a normal reaction N on the surface. If I draw a free body diagram, it will be something like this. It's 10g. It's a normal reaction N. And on the floor, this body is going to apply a normal reaction N. That's how things work. This 10 kg mass, 10g force is acting. Under the effect of this force, this could have moved with 9.8 meters per second square, but it's not moving, it's at rest. Why? Because there is a normal reaction. Its motion is constrained in downward direction. And who is constrained the motion? Motion is constrained by the surface, the floor. Floor is exerting a normal reaction N in upward direction. That's the reason why this 10 kg mass is at rest. N is balancing 10 g. As a reaction, 10 kg will also exert a normal reaction N on the surface. If I look into this case, again in this case, you have 10 g force acting on it. And under the effect of this force, this block should have moved with 9.8 meter per second square, but it's going down with 2 meter per second square. It means what? The motion is not, the acceleration is not 9.8 meter per second square, means the motion is still constrained over here. The acceleration is not 9.8 meters per second square, it's 2 meter per second square. So motion of this body is also constrained, but less constrained compared to this case. If I call this as constrained, I'll call under constrained. Constrained means what? Constrained is not free. The body is not going down with an acceleration which it could have had it been free. Had it been free, it could have moved with 9.8 meter per second square. But right now it is going with 2 meter per second square. It means that the motion of the body is constrained in downward direction. Had it been free, it would have moved with 9.8 meter per second square. It's going down with 2 meter per second square. It means it's still constrained, but not as constrained as this body. It is less constrained. So I call it under constrained. Another reaction, this body will also apply N force on the surface. Right. Surface apply N force N in direction opposite to the direction in which motion is constrained. So it's a case of under constraint. In this case, here you have 10 g. Had it been free, it could have moved down with 10 meter per second square. But instead of moving down, it's going up. It means what? It is over constrained. The motion of this body is not only constrained in one direction, it is over constrained. It's so over constrained, it's moving up. So in which the normal reaction N will act in upward direction. This motion is constrained in downward direction. 10 g is not able to move this body with 9.8 meter per second square in downward direction. Instead, it's moving up with 2 meter per second in upward direction. So it means surface exerting a normal reaction, which may be more than 10 g. So as a reaction, 10 g will also exert force N on the surface. So I'll call this over constraint, right? I hope you understand the meaning of constraint. Constraint means not free, not free. This is unconstrained. This is constraint, under constraint, over constraint. So you know the direction which the motion is constrained, normal reaction act opposite to it. Now let's talk about third point. What's the magnitude of normal reaction? See this case. Here you'll apply Newton's law. Force equal to mass into acceleration. Here the body is at rest. So net acceleration is 0. So net force acting on the body is also 0. Here you have acceleration in downward direction. So since you have acceleration in downward direction, net force will also lie in downward direction. So what is net force in downward direction? That is equal to the force acting in downward direction minus force acting in upward direction. That is the net force in downward direction is equal to mass into net acceleration in downward direction. The acceleration force must lie in same direction. Since I am knowing that it's moving down with 2 meter per second square in downward direction, the net force must be in downward direction. So net force in downward direction is 10 g minus n equals to mass into acceleration. Here in this case, the acceleration lies in upward direction. So net force should also lie in upward direction. So net force in upward direction is n minus 10 g is 10 into 2. Here in this case n is 0. Here n is 100 Newton. Here n will be say 80 Newton if g is 10. And here n will be 120 Newton. See the values. It's 0. Why? Because it is unconstrained. It's 100 Newton. It is less constrained, so the normal reaction has gone down. It's over constrained, so normal reaction is more than this. So it is highest over constraint. The constraint is higher over here. So the magnitude depends on the degree to which motion is constrained. This is unconstrained, so normal reaction is 0. This This is constrained normal reaction. 100 is less constrained, 80 Newton over constrained, so 120 Newton, right? So that's the meaning of what is meant by constraint, and that's how we discuss normal reaction. Okay, thank you very much.